Dear friends, welcome to my video lecture series. In this video, we will discuss the basic concepts of numerical differentiation and related problems. So, numerical differentiation. If you want to talk about differentiation, there are a lot of applications. For example, uh, the data, whatever they are giving, x values, x0, x1, x2, etc., y0, y values, y0, y1, y2, etc. So, suppose if we consider x as the time and y as the displacement, then what about dy by dx? Obviously, it is velocity. Then what about acceleration? d square y by dx square. So, uh, obviously, these are all the applications of the numerical differentiation. The first derivative, second derivative, third derivative, everything we are going to discuss here. It plays a major role in the day-to-day life application, particularly the mechanical field, flow dynamics, and everything. The derivative, wherever it's going to occur, we can apply this numerical differentiation concept. Now come to the topic. We will deeply discuss the basics here. Right. Newton's forward interpolation formula. Using that formula only, we are going to derive the derivatives, numerical differentiation concept we are going to study here. Right. This is the Newton's forward interpolation formula. You know very well. Already we discussed it in the previous video lectures. Y naught plus u into del y naught plus u into u minus 1 by 2 factorial del square y naught, etc. etc. Here, what is the value of u? How to find? U equivalent to x minus x naught by h. That's it. So now what I'm going to do here is just I'm going to multiply everything here. I'm going to multiply everything. How to multiply? Multiply everything here. So you the inside the brace. That's it. And nothing a new one. It's a simple one only. Simple multiplication. So u square minus 2u, and then multiply those terms. All the three. If you're multiplying all the three, you'll get u cube minus 3u square plus 2u. And then I have to multiply this everything. If you multiply all the three, you will get this. Again, multiply that with the u minus 3. So I will get this term. It will be u power 4 minus 6u cube plus 11u square minus 6u divided by denominator will be similar only. Numerator only I am going to multiply. I am going to write like that. Then only we can come to know uh, how it will be very easiest one here. Right. We'll continue now. So I'm going to multiply like this. That term only I have written here. Look at that. That's it. So first term u square minus u, and then again I have multiplied here divided by 3 factorial, and then this term divided by 4 factorial. Now I'm going to find the derivatives. So to find the derivatives, I will give the simple clue guys here. You no need to memory the formula. If you memory the formula, confirmly you will commit some mistakes here. You will do some mistakes here. So that's why do not memory the formula. Try to follow the clue, whatever I'm going to give now. Just write the Lagrange's interpolation formula. This is the way to find way to derive all the derivatives. First derivative, second derivative, third derivative with the help of Newton's forward interpolation formula. Similarly, we can do the same procedure for backward interpolation formula also, that we will discuss later. Listen now. So I have to find dy by dx. So that will be, I will multiply by one value here in front. So I will tell you that later. Here, to find the dy by dx, it's so simple. Write the formula, multiply everything. You have to differentiate this with respect to u. So listen very carefully. So you have to multiply with respect to u. So what you have to do here, now tell me what is the differentiation of this with respect to u. Here it will be 0. Here it will be delta y naught plus Again differentiated with respect to u. 2u minus 1 divided by 2 factorial. 2 factorial simply you can write, or divided by 2 also you can write here, into del square delta square y naught plus, what is the next differentiation? 3u square minus 6u, differentiate this with respect to u alone, plus 2 divided by 3 factorial into del cube y naught, plus again you can differentiate the for next term also, plus etc. So I am going to multiply the first derivative by 1 by h. I am going to find the second derivative now. D square by dx square. It is nothing but I will multiply by a value. I will tell you what it is later. I'm going to derive it. By the time you'll come to know how it will be 1 by h, it's in multiplication. Okay, fine. Now we have to differentiate this. If you're taking that as equation 1, take this as equation 2. Second derivative means what? We have to differentiate the first derivative with respect to x again. So instead of differentiate with respect to x, we are going to differentiate with respect to u here. I will tell you why it is later. Right. Now differentiate with respect to u. This will be 0 because u term is not there. Now differentiate this with respect to u. 2u differentiation is 2 minus 1 differentiation will be 0. So 2u by 2 factorial. 2 factorial value is 2 only. 2u by 2 value will be what? It will be 1. So it will be del square y naught. It will second derivative will start with del square y naught. First derivative will start with del y naught. That is a simple clue here. Plus differentiate this with respect to u now. 6u minus 6 divided by 3 factorial you can write, or 6 also. In some other book they will change this into 3 factorial is 1 into 2 into 3. Because you are going to use calculator only, so you can keep the same. We can insert the factorial there, simply we can calculate it. If you cancel, if you want, you can cancel it here. 3 factorial is 1 into 2 into 3. So it will be 6 only. 6 is 6. So you can, numerator you can cancel. I am not going to do in that way. Right. Just listen. 6 plus etc. The next term, if you are writing, you'll come to know what's happening again. So third derivative d cube y by dx cube, which is equivalent to here, for second derivative you have to multiply 1 by h square. Already 1 by h is there, again 1 by h will come, so 1 by h square. Now what about for third derivative? Obviously it will be in the multiplication 1 by h cube. Again differentiate this term with respect to u. So this will be 0. Here u differentiation of u is 1, 6 divided by 6. Here I inserted that del cube y naught. This will be there, plus etc. So now differentiate with respect to u. U differentiation with respect to u is 1. 6 divided by 6, it will be 1. So only del cube y naught will be there, plus etc. Next term, if you are differentiating this term, it will come by del power 4 y naught also. That's it. That's it, guys. This is the way to write the derivative formula or derive the derivative formula. First, write the Newton's forward interpolation formula, multiply everything inside the u values, and then differentiate with respect to u. If you want to find the first derivative, differentiate once and multiply by, throughout multiply by 1 by h. I will tell you the reason later. Right. Second derivative, d square y by dx square. Again, differentiate the first derivative with respect to u. So if you know this, the Newton forward interpolation formula, everyone knows that it is so simple. So we have to multiply the value of u inside, then we can get this. That's it. So if you are if you want to find the second derivative, it will be differentiate again the first derivative with respect to u. Third derivative means you differentiate the second derivative with respect to u. This is what we have to do here. What is the value of u here? U equivalent to x minus x naught divided by h. Now listen very carefully. I'm going to explain in detail how to derive the first derivative. Look at that. I have to find dy by dx. I have to find dy by dx, but x is not there in the equation. That's why I'm going to rearrange. I have u. So I'm going to write dy by du into du by dx. So what is u? X minus x naught by h. Differentiate u with respect to x. Differentiate u with respect to x. It will be 1 by h. X different u with respect to x we have to differentiate. It is 1 here x not only, so it is 0. So 1 divided by h will be there. Constant, this is constant is in multiplication. We have to get the same. So numerator x with respect to x is 1 and the derivative will be h. So that's it. It will be 1 by h. 1 by h into dy by dy by du you have to do now. So 1 by h is there. Dy by du. What is dy by du? This is y. Differentiate this with respect to u, as I told you already. For the first derivative, 1 by h will be in the multiplication and differentiate your Lagrange's forward interpolation formula. That is y equivalent to something. That equation will be there with respect to u. Dy by du. So 1 by h into this. That's it. So 1 by h into, if you are differentiating with respect to u, this one only you will get. So instead of writing like this, 2, 6, 24, for our simplicity, we can write this as 2 factorial, 3 factorial, 4 factorial. You can keep the same whatever you have in the Newton's forward interpolation formula. In some other book, they have written the factorial as 2 factorial is 2, 3 factorial is 1 into 2 into 3, 4 factorial is 1 into 2 into 3 into 4. You will get 24. Instead of writing like that, simply it's better. You can write the factorial itself, because we are going to calculate everything using calculator. So no need to bother about that. Right. So how to find the second derivative now? Again, I have to differentiate with respect to x. I have to find d square over by dx square. What is the meaning for that? I have to differentiate dy by dx with respect to x again. So I can't be able to differentiate with respect to x because everything it contains u only. That's why I'm going to adjust it. Actually, I have to find dy d by dx of dy by dx. So this is what the second derivative. Look at that d square, d square y by dx square. So instead of doing like that, we don't have any x here. Yeah, obviously x is it's understood. You use you can write in terms of x minus x naught by h only, but this is the way how to think here. So we are going to rearrange because entire thing there in u. That's why we are going to rearrange this with the u here. So what you can do here, it's equivalent to d by du into, do not disturb this, dy by dx into du by dx. Here it is u. So what I have done, is it clear? Do you understand the concept? Simple thing. I have multiplied and divided by du. If I cancel that, I will get the same answer. I'm adjusting with u. So what is the meaning for that? Uh, Again, du by dx is 1 by h. Already 1 by h is there in dy by dx. Now we will get one more 1 by h. That is, look at that, I have it. It is here. 1 by h. Again, you have to differentiate the first derivative with respect to u. So what you will get, already 1 by h is there. One more 1 by h will come. And then we have to differentiate this with respect to u again. So what we get if you are differentiating with respect to u again? This term, equation 1, you have to differentiate with respect to u. These are all the terms. First, this term, under this term, under this term. These are all the terms we have. We have to differentiate that with respect to u. So 2u minus 1, it will be 2 under 2 will be cancelled. It will be del square y naught plus 3u square differentiation 6u minus 6 divided by you can write this as 3 factorial itself, or if you want to write 6, you can write. I think it's better to write as 3 factorial plus 4u cube. It will be differentiation of 4u cube is 12u square minus 18 into u square is there. Differentiation of u square is 2u. 2 into 18 is 36u plus 22. Minus 6 is constant, it will be 0. So it is, you can write this as 4 factorial into del power 4 y naught plus etc. So here it will be del cube y naught. That's it, guys. So this is the way you have to find the second derivative. D square by dx square equal to 1 by h square into everything. Similarly, we have to proceed for the third derivative. It will be d cube y by dx cube. It will be 1 by h cube into del cube y naught plus 12u minus 18 divided by 12. They have written this. So this one only. They have cancelled commonly they have taken the values here and then they have cancelled that. So d square y by dx square, instead of writing 12 they have cancelled by 2. This term is there, this term they are differentiating. Actually it will be 12u square minus 36u plus 22 divided by 24. I mean 3 factorial will be there. So the 2 they have taken as common, they cancelled here. Do not get confusion. Simply what you can write, 12u square minus 36u plus 22 divided by 3 factorial you can write. No issues. Clear? This is what you have to write. So for the next derivative, you have to do that way. You have to differentiate this again with respect to u. We can get this answer. This is the way to find the first three derivative, guys. Using forward interpolation formula, we are deriving the first derivative, second derivative, third derivative formula. All are for what? Forward interpolation, because we have taken forward interpolation formula only. Similarly, we can prove the same for backward interpolation formula. Uh, you no need to derive again the everything. If you know how to derive the value, I mean, the derivatives for forward interpolation formula, it will be easy to write the backward interpolation formula. What are the notes you have to follow there? It will be first one is we have to change instead of y naught, it will be yn. And second thing is instead of delta, we have to use del, backward interpolation operator, backward difference operator. Third one is instead of using u, we are going to use v. If you want, you can use u itself there, no issues there. It won't be wrong. And the fourth one is everything in the terms inside included, wherever you are getting negative symbol, everything will be positive. These are all the four difference or four changes you have to make to get the Newton's backward interpolation formula for first derivative, second derivative, third derivative. If you know the first derivative formula for forward interpolation, second derivative formula, third derivative formula, in that one, if you are making these changes, we can get the backward interpolation formula, right? Now, we have one condition at x equal to x naught, what will happen? You no need to memory this formula separately. If you know the formula for first derivative, second derivative, third derivative, from that one only we are going to substitute this value. If x equal to x naught, what is the formula for u? U equivalent to x minus x naught divided by h. So it's equivalent to, now x equivalent to x naught. What will happen? X naught minus x naught divided by h, the value will be 0. So u is 0. So we have to give u equal to 0 in the first derivative. We can get this formula. You don't need to memory this, guys. It's my, we can take that as a request also. Please do not memory the formula. Try to understand how to derive and what are the concepts we are going to apply that. Just understand. Do not memory. If you memory that, confirmly you make some mistake, plus or minus mistake in the formula or some other constant term, you will miss. So it's my kind request. Do not memory the formula. Right. So if you are at x equal to x naught, then we will get u value will be 0. So u value will be 0. You have to substitute in all the formula. So if you substitute u value 0 here, what will get? Del y naught minus 1 by 2 del square y naught. Here u value 0, 2 by 6 is 1 by 3. 1 by 3 del square y naught. Here 6, 1 by 4 minus 1 by 4 del power 4 y naught. This is what you will get here. That's it, guys. So do not memory the formula at a particular value. For the particular case, do not memory the formula. If you know the formula for first derivative, second derivative, third derivative, both in forward interpolation as well as backward interpolation, then we can substitute the particular value. No need to go for the particular value, no need to memory for the particular value. Good. So similarly, substitute u equal to 0 in the second derivative, you will get this one. Substitute u equal to 0 in the third derivative, you will get this one. That's it, guys. This is the way to derive the Newton's forward interpolation formula for derivatives. Next, I have given the same for Newton's backward interpolation formula. You no need to, here I derived everything. You no need to derive that. I try to do use the clue what I have given already in the first uh, difference. The first derivative already we derived in the Newton's forward interpolation. There you have to change forward operators, backward operators, y naught by yn in all the places. I mean u by v, u by v, and all the places wherever you are getting negative, everything will be positive. That's it, guys. This is what the difference when you compare the forward interpolation and the backward interpolation. What are the four differences? I will repeat it again. Change y naught by forward, it will be first value y naught. Backward, it will be last value, it is yn. Second one, change the operator. For forward operator is delta and the backward operator is del. Third one, for our convenience, for our simplicity, we are using u in forward, v in backward. So replace u by v. Fourth one, wherever you are getting negative sign, everything will be positive in backward. This is forward, this is backward. That's it, guys. You no need to memory the formula both. If you know one formula, we can write everything. Similarly, find the second derivative. Here I derived, you no need to derive again. So differentiate this again with respect to v and multiply by one more h, 1 by h, it will be 1 by h square. Similarly, 1 by h cube will be the third derivative formula. Right. Similarly, at v equal to, x equal to xn. What is v formula? V equivalent to x minus xn divided by h. What you will get? This is h. So x value is xn. Then what you will get? 0. V value 0. V value 0, we have to substitute in the first derivative formula and the second derivative formula. If you are replacing v equal to 0, you will get this. The third derivative formula, if you replace v by 0, we will get this. You no need to memory. The derivative formula is enough. If you know the derivative formula, at the particular point, whatever the value v we are getting, we can substitute there. That's it, guys. This is the way to derive the forward interpolation formula for derivative and backward interpolation formula for derivatives. Right. Now, I have chosen a problem to explain the concept. A population of a town is given below. Find the rate of growth. So before to answer the question, you should read the question very carefully. Find the rate of growth. They didn't, the same kind of problem will be there in the interpolation previous chapter. Interpolation. Do not confuse that with this. Find the rate of growth of population. Rate of growth. Rate of change. Rate of change. It is nothing but dy by dx. Rate of growth. Look at that. Rate of growth of population in years with respect to years. Rate of growth is y. Rate of change is y with respect to x. Dy by dx they asked to find. That one only they have given uh, in a different way. Find the rate of growth of population with respect to these years. 1931, 1941, 1961, and finally 1971. That's it. So If you want to find 1931 and 1941, it is before the middle level. So we can use forward interpolation formula for first derivative only we are going to find, not higher derivatives. Rate of growth of population with respect to year means y with respect to x, dy by dx. Derivative of y with respect to x. Right. So 1931 and 41 before the middle level we can use forward interpolation formula for derivatives, and 1961 and 71 it will be after the middle level we can use backward interpolation formula for derivatives. Yes. Now come to the problem. First form the difference table. Difference table is similar, guys. What we followed the concept to find the difference table in the interpolation for equal intervals. The same concept we are going to use here because it is equal interval only, simply if you want to say. Right. We found the difference table. X values are here, Y values are here. Could you remember how to find the difference table? Yes, tell me exactly. This minus this. 20.18. 79.95 minus 60.80. Next value minus that value. Do not do the mistake, guys. P members, they will subtract this minus this. It will be wrong. It won't be like this. It should be next value minus the previous value. It equal to this. Similarly, subtract this. You can get this value. And then finally, 132.65 minus 103.56. You can get 29.09. Similarly, try to find the rest of the differences. Second difference, third difference, and finally fourth difference. Until get the single value, we have to proceed. Right. We found the difference table. Now we have to find the population, rate of growth of, not population, rate of growth of population. I mean dy by dx of 1931, 1941. For that one, we are going to use forward interpolation formula. For 1961 and 71, we are going to use backward interpolation formula because it's after the middle level, right? Newton's forward interpolation formula for the first derivative. First derivative only we are going to find here rate of growth of population. dy, y is population size, x is year. So with respect to year, what is the change of the population? That's what they asked, the rate of growth of population, right? This was the formula. Now we have to find the value of u. First one, to find the rate of growth of population in 1931. That is y dash. Y dash means dy by dx at 1931. That is x equal to 1931. Whatever the value we are going to find, you know very well, that will be our x. Right. Now we have to find u value. This was the formula. We have to find u values. Value of u is x minus x naught by h because it is forward. So it will be, we are getting 0. So wherever you are having u, replace by 0, and the del y naught, del square y naught, del cube y naught, everything we can take from the table itself. Look at that. That's it from this. Del y naught, del square y naught, del cube y naught, everything we can take from the table itself. This is for forward, and backward similarly we can del y naught. This is delta square y naught. This is delta cube y naught. This is delta power 4 y naught. Similarly, while we are solving for backward, we will choose the last value in the differences. It will give the del, look at the operator, it is del, not delta. Del, last value it is, that's why we are going to write yn. This is del square yn. This is del cube yn. This is del power 4 yn. So, and similarly, x value, first value of x is x naught, last value of x is xn. Similarly, first value of y is y naught, last value of y will be yn. So these values only we are going to consider to solve the problems here. That's it. So this was the formula. We found the value of u. It is 0. Then replace it. So 20.28 it is the del square y naught value. Del cube y naught value is this. Del power 4 y naught. Del cube y naught and del power 4. This is del y naught, del square, del cube, and del power 4 is minus 4.47. And if you substitute u value as 0, you'll get minus 1 by 2 plus 1 by 3 minus 1 by 4 here. Simplify this, and most of you will forget to multiply by 1 by h here for the first derivative. As I told you already, 1 by h will be there in the multiplication. This will be, this will multiply the entire term. Someone they will forget to use a brace here. If you are not using brace in that place, it is meaningless. Only it will divide this, and for the rest of the values you have to add. So it is meaningless. The brace should be important one. Bracket should be important one. So simplify this. We can get this answer. 2.36425. Here we can't be able to compare the result, guys, because it's a derivative one. We can't be able to check the results here. Right. Similarly, for 1941. For 1941, we have to find the rate of growth. So x is 1941. Then what about u value? X minus x naught by h. Our x value is 1941 now. So 1941 minus 1931. Then 10 by 10 divided by 10 value is 1. So in the above formula, replace this is what the formula. In the formula, replace u by 1 and take del y naught and del square y naught, del cube y naught, del power 5 y naught from the table. Simplify this, we can get the answer 1.83775. This is the first derivative value, I mean rate of growth of population in 1941. That's it, guys. So similarly, we can find, we can use the backward difference operator. Backward difference operator, you no need to memory the formula. Operator, instead of forward, del, instead of y naught, yn, instead of u, it is v, and all the places will be plus, negative sign in places will be plus. That's it. These are the differences we are going to write in the backward interpolation formula for derivative. Look at that. This operator changed here yn, here plus, and u changed by v, and everything will be here. Fine. Okay, first 1961. So at 1961 we are going to find, therefore x equivalent to 1961. What is the formula for v here? X minus, is it x naught by h or xn by h? Exactly, it is xn by h. That's it. So xn value is 1971 divided by h is equivalent to minus 1. So v value is minus 1. We have to substitute v value here. And the del yn, del square yn, del cube yn, del power 4 yn, we can take from the table. The last and the end values represents the del yn, del square yn, del cube yn, del power 4 yn. So substitute in equation 2. Simplify that. We can get this answer. So the rate of growth of population in 1961 is 2.65525. Now the last one, we have to find the rate of growth of population in 1971 next. Okay, 1971. Then what about the v value here? X minus xn by h value will be 0. V value will be 0. X minus xn, that is the important one, guys. Here for backward it is u equal to x minus xn. For forward, first value of x. Backward, last value of x. That is the important thing. That's it. So substitute v value equal to 0 in the above equation, the first derivative equation, and take the del yn value, del square yn value, del cube yn value, del power 4 yn value, and simplify that. We can get the final answer. It is 3.10525.